One thing we need to talk about is how the sun, which you see as my microphone, is holding everything together. It's actually called the solar system, and it's named after Sol, our sun, the closest star. A question I get all the time from kids is, hey, there's gravity on Earth, but is there gravity in outer space? Well, we can do a simple demonstration with this high-tech stuff to show that yes, there is gravity in outer space. Because without gravity in outer space, this is what would happen. On the count of 3, no gravity, and we have boom, no planet in orbit. In fact, planets are just flying on out. So there is gravity in outer space. Let me see the Earth back in here again. So I use equipment like this. It's all about the stuff. You know, so for example, here is something you can try. This is a hula hoop. A hula hoop, a toy from when I was a kid. Now it's a science demonstration with another Nerf ball. So I'll tell you, we did a few fun little experiments here in the stadium, how we can learn just a little bit about eclipse season using hula hoops. So why don't we have total solar eclipses all the time? Well, evidently there is a eclipse season. And I'm going to try to show you what that is with my buddy here, JC from Maplewood, and his dad, who's a 6th grade teacher there. JC, once again, you're going to be Mother Earth. Sorry, dude. Go ahead and put it on. We have the infamous Earth helmet, or I like to say globy here. And so we know that the Earth rotates, so we're rotating around. Let's see if we can get us right about where we're going to be here in North America. So the Earth is rotating and going around the sun. We call that revolution. It takes about a year. And so we're going to use this hula hoop here as the sun. And if you can see, the sun and the Earth are on the same plane. That's called the elliptic. It's elliptic. It's like, oh, in the old days, we used to have record players. It's like this is the middle of the spindle, and this is the record going around. And as this goes around, that's one entire year. From the Earth, it looks like the sun is going around, but we all know that it's the Earth that goes around the sun. We don't have a geocentric system, we have a heliocentric, and it took hundreds of years to figure that out. Let's stop right there. So you'd think there'd be a sun and a moon eclipse all the time. Well, that's true if the moon's rotation and revolution around the Earth was the same. If it was the same, we'd have them all the time. As the sun's going around, apparently, and the moon, we'd be coming back and forth bunches of time. But it's not like that. Let me show you how it really is. We have that elliptical, we have the moon tilted at 5 degrees. And so if you look, there are 2 times in the year, we call that the eclipse season. Right here, here's one of them by me. This is called a node, and here's another node right there. So as you can see, as it takes a month for the moon to go around the Earth, and as the sun appears to be going around, there's going to be one time coming up right about by my chin here in just about a second where, boom, look at that, a little bit more, and we have the moon blocking out the sun from the Earth. And when is the other time? 6 months later, the sun and the Earth are still moving in their orbits, they're elliptic, and right about here, boom, and you can see, we can't see the sun because it's blocked out the moon. And that is why there's 2 times a year when you can have these really cool total eclipses. But there's a little more math involved in it that you can learn with the help of your teacher. You take a globe, you take a bicycle helmet, you put it together, and you have a great science model of rotation and revolution. You know, I'll tell you, there's an organization that does this really well, and it's located in Chicago. It's the Adler Planetarium. Maybe you visited there. If not, that's a great trip from Indiana. Check it out. Hey, let's see what Lynette Morse, who is the programmer at the Adler Planetarium, has to say. Rick Crosslin here at the Great American Total Solar Eclipse in Carbondale, Illinois. And I'm here today with Lynette and Adriana from the Adler Planetarium in Chicago. Lynette, you're from Chicago. What are you doing here in Southern Illinois?
A team of us from the Adler Planetarium came down to Southern Illinois on Monday, and we have been visiting schools, libraries, nature centers, science museums all over the area to talk about the solar eclipse, why it happens, what to expect, how to view it safely.
And so your planetarium, you do more than the eclipse. What do you normally do at the Adler Planetarium in Chicago?
We are an astronomy and space museum, so we cover all topics under those realms. We have 2 domed theaters with shows, exhibits with historical objects like astrolabes, sundials, and telescopes, and then other exhibits on space exploration and astronomy.
And teachers and students can come to it?
Yes, lots of teachers and students visit the Adler Planetarium every year.
Okay, this question is the question that everybody's been asking. How do you make a total solar eclipse?
You need 3 things. You need the Earth,
The Earth,
the Moon,
the Moon,
and the Sun.
and the Sun.
And you need them lined up in just the right order and at the right distance to make a total solar eclipse.
So to help us understand that, I think you brought some things and some activities you do with school children and the public. And so can you show us what you got today?
Yes, absolutely. So to start out, we're going to talk about how far away the Moon and the Sun are from the Earth. So if we could take our entire planet Earth and shrink it down to this size right here, then our Moon would be this size right here. Now my question for you is, if the Earth is this size and the Moon is this size, how far apart are they in our scale? Are they this far apart? Are they this far apart? We're going to try this out and see. I have some friends here to help me. JC is going to take the Moon. Adriana is going to hold the Earth, and JC is going to take the Moon. And let's see, let's put Adriana right here. And
Okay.
JC, you get to walk up the stadium steps here. Go a little ways, see how, stop when you think you've reached the spot that accurately measures the distance between the Earth and the Moon.
And this is to scale, right?
This is to scale. If our Earth was this size and our Moon was that size, how far would they be?
What do you think, JC? Right about there? Hold up the Moon. Let's see. What do you think, Lynette? Is that a good?
Oh, let's try this out. Okay, so Adriana, I'm going to take the Earth from you, and you know what? This is our scientific purple
Yes.
measuring yarn.
Is this an
that-
astronomical unit?
It's an astronomical unit. This accurately measures the distance at this scale. So Adriana's
Okay.
going to take this. You'll take the end all the way up to JC. I'm going to hold the end here with the Earth.
Okay.
Adriana's going to make the trip up there, and it's a little bit longer than you might have guessed because it's a big distance.
Now, we've had people that have traveled this distance. The Apollo astronauts traveled from the Earth to the Moon, and it's still going? Still going?
Yeah.
Let's see.
Oh, wait,
there.
let's see. Okay.
Okay.
She's still. Oh, JC's going to have to move up
Yeah.
the steps a
Here you
little
go.
bit more.
JC, hold on.
This distance to scale is 30 feet. So if our Earth is this size and the Moon is the size of about a tennis ball, the distance between them is 30 feet. Now you're right, astronauts did travel this distance, and they did it in, about 50 years ago in the late 60s,
Yes.
late 70s, in rockets that went like 4,000 miles an hour. Traveling that fast, it took them 3 days to
3
reach
days
the Moon.
to get to the Moon.
Now that's kind of a hard number for us to imagine. Let me tell you this. If you could imagine that this purple yarn was a highway, imagine that we have a highway that goes from the Earth to the
Yes.
Moon. If you drove that in a car at 75 miles an hour,
Mhm.
and 75 miles is about how fast we can go on
Yep.
our highways, 75 miles an hour, you cannot stop to sleep or to eat or even to go to the bathroom. Non-stop at 75 miles per hour, it would take you 4.5 months to drive to the Moon.
Wow.
That's like from now until like Christmas.
Yeah.
That's a really
That's
far distance.
That is. But it helps us understand the scale. Of course, my students, the first thing they would say is, you can't drive to the Moon.
You can't drive. Let me tell you this though, if we were to add the Sun to this scale,
Yes.
it would be a little over 2 miles past JC and Adriana up there. A little over 2 miles away.
Wow.
Our solar system is vast, and our Moon is the closest thing to
Yeah.
us. So it's a pretty amazing thing to think about.
But when I look at that Moon so far away, it looks so small compared
And-
to the Earth.
And so we wonder, how can our Moon that is so small cover up the sun that is so enormous. Do you know how that can happen?
No, that's a great question. How can a small thing like the moon cover up the sun? Are they the same size?
Because the moon is closer to us. And one way that we can try this out is to take your thumb
Okay.
and look up in the ceiling of your classroom, maybe at a light or a spot in the ceiling, and try to cover that up with your thumb. So put your, you might need to wink one eye closed and put your thumb out. And if you can't quite cover it up with your thumb, put your thumb a little closer to your eye.
Okay.
And so cover it up. Now you know that your light in the ceiling is bigger than your thumb.
Yes.
But your thumb is closer to your eye. So it's like if your eye was the earth and your thumb is the moon, you're covering up that big sun because the moon is so much closer to us than the sun.
And that's something anybody could do to do that.
To try that out, yeah, to get a sense of that. So for a total solar eclipse to occur, we have the earth, the moon, and the sun all lined up in the right order and the right distance. People sometimes don't realize that, the sun is always in the same spot, but it does rotate. The earth revolves around the sun, and then the moon revolves around the earth, and they don't do it at exactly the same distance. Sometimes the moon is a little bit closer to the earth than at other times. Sometimes the earth is a little bit closer to the sun than at other times. So they have to line up in the right distance and in the right order to make a total solar eclipse.
And that affects the shadow, the umbra that hits the earth.
Right, exactly.
So is that when I hear the difference between a partial and a total eclipse?
Yeah, so a total eclipse is when that lineup is exactly perfect and the moon totally covers the sun. If you're seeing a partial eclipse like you are in Indiana, it's just that from where you're viewing it, you don't quite see the entire sun covered up. You see a part of it covered up. The path of totality is about 70 miles wide. So there's the very center where the shadow goes, and then about 35 miles out in each direction. And then after that, you don't see the totality, but you see a bit of it. And that's why people across the United States are so excited about this eclipse, because it's coming all the way across our country, from Oregon, coming down through southern Illinois, and then going to South Carolina. And that's an amazing thing that it's going to cover the whole country. So even if you're not in the path of totality, you get to see some of the eclipse.
That's pretty amazing. That's why it's called the Great American Total Solar Eclipse, when a small thing like our moon can cover a large thing like the sun. Lynette, that's amazing. We've learned a lot more thanks to you in the Adler Planetarium. And I think we'll end this with the sun covering up our camera. That was pretty cool. We need our stuff. We need our stuff. And I like to end this segment with a very expensive and hard to make science instrument I use to study the sun. PVC pipe, a coat hanger from my daughter's closet, and a little red ball. But you know what? With a little bit of thought and ingenuity, I have an object that revolves around my head. I tell you, necessity is the mother of invention. When you need something, you invent it.
I'm Mrs. Army, and I teach 6th grade at Westlake Elementary in MSD of Wayne Township. There's a lot to learn about the Great American Eclipse in 2017. Did you know?
The sun is 93 million miles away from the Earth. If we could ride in a car to the sun, it would take about 160 years to get there. Ta-da!
What about the speed of light? If we could travel at the speed of light, the 160-year trip will only take about 8 minutes. It takes about 8 minutes for sunlight escaping the sun to reach the earth.
Ta-da! Wow, thanks for that information.
Now you know!